All right, so now we're going to be taking a look at finding the vertex. We've actually already done this on the last 3 examples because we had to find the y-coordinate of the vertex to give our range. So this information really isn't anything new. The vertex, again, is where the parabola turns. So I've got that highlighted on my graph kind of as a bullseye. It always lies on the axis of symmetry. We've been using that information too, finding the x-coordinate of the vertex to get the equation for the axis of symmetry. And then we substitute that value in. We saw that on one of the examples to get the y-coordinate of the vertex. Unless it's already in vertex form, and then we don't have to do as much work. All right, so we're going to start with an equation. First of all, what I would like you to do is think about, step 1, what information do we have? And what information will we use to find the x-coordinate of the vertex? All right, hopefully you decided that this is in standard form. This equation is looking very familiar. We've got one little piece that's a little bit different. So we are going to, first of all, find the x-coordinate of the vertex by using our negative b over 2a formula. In this case, a is 1, the coefficient of our x squared. B is negative 7, the coefficient of our x variable. And c is our constant. We don't use that for our axis of symmetry or the x-coordinate of the vertex. Substituting those in, the opposite of negative 7 is positive 7 over 2 times 1. So this time we have an x-coordinate of our vertex of 7/2. So to find the y-coordinate of our vertex, we substitute that back into the function. And since I don't have my calculator nearby, I get to do some fun math with fractions again. So you can take a look and make sure that you know how to work with fractions. I think that's an important skill. So we get 49/4 again, minus 49/2. So this looks to me like it is the same that we had before. So I'm just going to jump to that answer we got before, negative 1/4. So the coordinates of the vertex, remember your vertex you should be writing as an ordered pair. We had 7/2, negative 1/4. Sorry, in step 3, substitute the x value into the equation. We did that. And then our last piece, we're looking for that domain and range again. So the domain for any quadratic function is all real numbers. The range uses the y-coordinate of the vertex and whether or not the graph opens up or down. The coefficient of our x squared is positive, so our graph opens up. So y is greater than or equal to negative 1/4. Last example. This time, think about which type of equation we have, standard form, factored form, or vertex form. And think about how you will find the x-coordinate of the vertex. All right, so we have our equation in factored form, which means we're given the x-intercepts. Now notice that they're both in parentheses. These are in the asylum, so our x-intercepts are actually -5 and +2. To find the x-coordinate of the vertex, let me label these. We average our x-intercepts. So the x-coordinate of our vertex is -3/2. Step 3, substitute that value into the equation to solve for the y-coordinate of the vertex. And I'm going to convert my integers to common denominators as well so I can add them a little more easily. So 5 becomes 10/2, 2 becomes 4/2. So we get 7/2 times -7/2, or -49/4 for the y-coordinate of our vertex. So we write our vertex as an ordered pair. And lastly, find that domain and range again. The domain for any quadratic function is all real numbers. The range, we use the y-coordinate of the vertex. And to figure out if that vertex is a maximum, the graph opens down, or a minimum, the graph opens up. We take a look at our original equation. Because there's no multiplication of a negative outside the parentheses, our graph opens up. So this is a minimum value, so y is greater than or equal to the y coordinate of our vertex. And your U-try problem.